Alrighty, thank you. Thank you, Paul. We will now transition to a power technical showcase. The goal of this session is to have a deep dive live demo to showcase how to connect and access data, all emphasizing the depth of Power's data catalog. I'll hand it over to my teammate, Bradley Macpherson. He has been supporting the Power project for 6 years, leading to the development activities including data processing frameworks, data service enablement, and hosting and distribution systems. Bradley, to you.
Thank you, Madison, for the introduction. So, Power supports a wide variety of users located globally, since Power does provide data from our data partners at the global scale. So we can support the three main communities: renewable energy, sustainable buildings, and agroclimatology, though we're not limited to just those use cases, as you'll see in some of the lightning talks later. So Power supports data distribution to enable access for analysis, decision-making, and implementation of workflows directly. So throughout this presentation, we're going to showcase how to use or how to access the Power data and give technical demonstrations of how to use the data efficiently. So here's the impact of the Power data. Power previously started in 1999, where we did not have geospatial data capabilities. From 1999 to 2018, Power provided almost 36 million API requests and sent about 3.6 terabytes of data to the users. So that's a large volume of data. But after we implemented our geospatial data services, our enhanced API capabilities, and more data access methods like the geospatial data services that we'll talk in a little bit, the number of data requests drastically or exponentially increased to almost 240 million data requests, and we've served out over 31 terabytes of data, though that number is not fully accurate because we only have metrics for the last year and a half, so that number is probably a lot higher. But our users is unique IP addresses is 560,000 users, which is a lot of users globally. If you look at the bottom right map there, you can see just for the last month where our users are located in the red and where they're requesting data for in the white. This shows that the dispersed data for different users, as well as where our users are located globally. So Power prides itself on being able to support people from all over the world with the data they need to conduct their specific analysis. So in a general average month, we support about 4 million data requests, sometimes a lot more, and we were on an average of 17,000 unique users. We're number 2 inside of the Open Data Portal for NASA. The only one higher than us is meteorite impacts. And then we have the most highest viewed item on NASA ArcGIS Online, which is our data access viewer that Shaquel, a little bit of preview, will be demoing towards the end of this demo session. So to support these data distribution numbers, Power has steadily transitioned its technology to support more efficient and more native or more advanced different data formats and distribution methods. We first started out on doing an ASCII-based text system that Paul mentioned earlier in his presentation. It was very efficient. It provided a lot of good information for the users. But in 2018, we migrated to use a stacked NetCDF system that enabled compression and allowed for direct access of a subset of our data through OpenDAP and supported our APIs to enable faster distribution of custom formats and time series. So that's in 2018, we started to do the API. We have more optimized data formats. Starting in 2021, we've transitioned all of the data to the Amazon Web Services Open Data Registry, which enables public access to over the 10 terabyte data. So we'd like to thank NASA as this Earth Data in partnership with Amazon Web Services for the NASA Space Act agreement that allows us to host and provide that data to the users free of cost for access. So it's a big accomplishment now that, and we'll demo this in a little bit, that you can access the entire data archive, all 10 terabytes, programmatically, or you can download it to your computer if you have a big enough hard drive. So that is our data format. It allows for, again, time series data, way better compression, faster response times. you can go right into one of those chunks to get only the data you need. You don't have to download all 10 terabytes. You can download your little bit of data that you need to conduct your analysis. And we also provide the netCDF files as day-based files. So you can download 1 day of data for all the parameters for 1 hour, for 1 day at the hourly level, or you can download all for a particular month without having to use either our API or the direct access that we provide inside of the Open Data Registry. Okay, so now we're going to go into a quick live demo. So I'm going to just give you a brief overview now of what we're going to go over. First, we're going to talk about the application program interface. I'm going to do a couple of quick requests to be able to show how to access and receive a response. Then we're going to go into the Amazon Web Services Open Data Registry data that's in S3. We'll navigate around and we'll download some data and show how you can directly connect with those. Then we're going to go through the geospatial and image services, and then we'll do some demos of the Power website and a story map just to get familiar with the different web portals and different places where we keep our documentation. So hopefully, if you have questions, that's your first stop, and you should be able to answer most of those for the users. So now I'm going to screen share very quickly, so give it 1 second to load. Okay, so first stop to go for any of this information would be the Power homepage. So on the Power homepage, we have our data access methods listed, our services, more services, direct links to different key documentation segments that are needed. And we also have a parameter data dictionary to help you locate the parameters that you need. Then we also have a quick overview of our data providers and how we make them available in the different time series, as well as direct connections to our release notes, publications, and frequently asked questions. From there, I'm going to jump just by clicking on this link to the data access landing page. Actually, I'm going to click here because it's zoomed in for you all to see. So inside of here, you're able to learn how to construct an API request outside of the API endpoint. So this enables users to construct it outside of using the data access viewer, which we're going to demo later. So for instance, we go to the daily, you open point or regional tool. I'm going to demo a single point request. You can click try it out. You just follow the prompts here and type in a time period. So I'm going to go 2020, 0101. Whoops, add an extra 0. No, I didn't. Okay. Then I'm going to add 2012, 31. I'm going to pick a location randomly. I'm going to say 50-50. Then you pick a user community, and this allows you to specify the units that your data is going to be responded in. So I'm going to pick sustainable buildings community. I'm going to pick the temperature at 2 meters parameter. The only caveat to using this is you'll have to know the parameter abbreviations, but we do have tools that Shaquelle and Christopher will demo later where you can find those. Then you can pick your data format. So depending on the different community, different format options will be available. So we have CSV to open in Excel. We have a JSON response that you can open in ArcGIS or different geospatial tools. We have ASCII files, which are just text-based files, netCDF files, and then we have ICASA, which are specific to crop modeling. And then we also have, for the hourly level, we have the EPW format, which is the Energy Plus weather format that enables direct integration into those modeling tools. So once you fill out all this, you just scroll down and hit execute, and it'll very rapidly respond back with a time series in this response pane. You can also copy and paste this URL that's created and throw it into your internet browser and respond. So this is just a JSON response, but also if I zoom back out, we can change it to another format like ASCII and hit our execute again, and it'll respond back with a file object where I can download the file and then open it, and you can see the time period information that way. So we provide direct access to the analysis ready data to be used. Okay. So next, moving on to the Amazon Web Services Open Data Registry, the NASA Power project worked with that space factor agreement to add all of our data to that catalog. So if you look here on the left, we have a description of the data product. Then we also on the right side have the resources and the bucket names so you can directly connect and use that data. So the first bucket here is the ZAR Analysis Ready Data Store. That we have tutorials that'll show in a little bit how to directly access it in Python and other scripting languages, as well as the netcdf files. You can do the same thing or directly download them to your computer because they're a more manageable file size. So inside the data browse for the Analysis Ready Data Store, you can see the ZAR files. Then you can also see that we have JSON time stamps in here of when the last time the data was updated. So if you wanted to programmatically determine when to update your data based on the availability of our catalog, you can do that from here. Sorry, the little banner thing's getting in the way. So same thing for the netcdf files. If you go to version 9, which is our current version, you can click daily, and then you can go through and go to the month you want, and then you can pick the particular file and then download that by clicking it directly to your computer, and then you can open that in whatever tool you use to open a compressed or a netcdf file. Next is our geospatial data services. So we provide annual and meteorology-based ArcGIS image services for direct integration into geospatial software, specifically ArcGIS or QGIS. And we also provide feature services, particularly the rolling thermal zones that allows us to build difference maps of thermal zones as well as that image that Drew Crawley showed with the progression of the thermal zones from ASHRAE, those as well. Now we're going to go into our story map. So Power also provides a single resource to enable access to our documentation. That enables users to scroll through themselves by these different sections to get data information, instructions on accessing data, review some user stories, as well as direct links to specific pages of our documentation. And last but not least here for me is one key thing I wanted to go over is all this information that I just went over very quickly. There's a lot of information on our documentation page. This includes our methodology, our data services in detail, and it gives like status updates and how everything works, as well as all of our references to the different scientific documentation that we use to either validate or implement our changes to the code. Also, we provide tutorials, and then we do provide a gallery of different cool and interesting maps that the community would like to see. So now I'm going to pass it over to Christopher Hyman, and he will demonstrate how to use our Access notebook.
Thank you, Bradley Macpherson. Yes, my name is Christopher Hyman, and I'm with the Power team, and I'm excited to do this demo with you guys today, with everyone. The purpose of this demo, as Bradley alluded to, is to demonstrate pulling a subset of data using one of our APIs with the help of Python, Jupyter Notebooks, and the Pandas Python library. In this case, we will execute a daily single point request for several solar data parameters for 1 year of time. We start by importing the necessary Python libraries. Please note that we import Pandas, which is a popular Python library for data access and analysis. We also are using the JSON and requests libraries. That will be important specifically for requesting the data with the API. The next step is to set several variables that we will use in our API request. As mentioned, our temporal level is daily, meaning we want one row of values for each day, and our time range is the year 2001. We have selected a location in the UK and 4 data parameters. Next, we will build the URL that makes the API request. Python makes it easy to inject our variables into a string using the string format method. You could copy the URL in a new tab or click the link, but we want to use the data in our notebook, so we will load it into memory. For more information on how to build API URLs with Power Data, you can visit the Power Docs API page that Bradley Macpherson referenced. Using the requests in JSON libraries, we can easily pull the data into memory on our computer. We can view and inspect our data set using a pandas data frame. In this case, we set the index column to the date for each row. Using pandas, we can also instantly access statistics using the describe method on our data frame. And finally, the API request also gives us access to the metadata, including short name, long name, and the units. In our case, if we had chosen a different community, we would have different units for the same parameters. Speaking personally, sometimes the short names can be a little bit confusing, even though all, all sky surface shortwave downward irradiance, the first parameter listed, that is all in the short name, but the long name offers a better description. We will make this and other notebooks available at the end of the conference. I hope this has been beneficial to you. Other notebooks include accessing power data in the Open Data Registry directly from Amazon Web Services, and a use case example calculating anomalies. But like I said, those will be available at the end. That's all I have. I will now pass it off to Shaquille McNeil, who's working on what I think is one of the most exciting services that Power has to offer. So thank you, Shaquille.
Thank you for that, Christopher. So if you give me a second, guys, I'm going to share my screen. Just give me a second for this to load up here. Okay, I think that's up for everyone. All right, so I'm Shaquille McNeil, and I've been working with the Power Project for a little over a year and a half now. And during that time, I've been mainly focused on the development for the Data Access Viewer Enhanced, which we'll be taking a look at today. What we have before us now is the Data Access Viewer that was alluded to earlier throughout this presentation. What I would like to do is start by doing a simple single point request within the Data Access Viewer, just so we can get an understanding of our current functionality before we jump into exploring some of our new functionality within our Data Access Viewer Enhanced. So with that, you'll see that within the Data Access Viewer, we currently have our single point tool pulled up within the application. From here, you're able to actually go in to this form here and complete the form, and we'll be able to make a request for a single point data return. Our first drop down here displays our user communities that we support: renewable energy, sustainable buildings, and agroclimatology. These selections will have effects on the parameters that are available within the form, as well as any unit changes that are needed for those given communities. You're also able to select, of course, your temporal level here. We're going to stick with daily just for our demonstration purposes. Next, you, of course, will select your location that you will want to request data for. You're able to click here to get that to auto-populate within the form here. Of course, you would also select a date range. This is a default date range auto-populated, but you're able to customize that as well within the form to your desired date. We also have some different formats available directly within the application. You're able to click here to change depending upon how you would like that data returned once we make the request. We're going to stick with JSON today for the demonstration. And here is where you select your parameters. And so, as I noted before, some of these parameters may be different depending upon what community is selected. But once you select a parameters here, you're able to go in and just choose whichever ones you are if you want to display for your current request. We're just going to select temperature today for demonstration. I'm going to go ahead and submit this. All right, let's expand this to get a good look. So what we have here is our application reached out to our Power API, and then this data is returned within the application here to make this chart. This displays the data, of course, that was requested based upon what you input into the form. You're also able to directly download the JSON file here after the request is returned. And then as for our other capabilities, besides just single point, we do also offer some regional capabilities and requests that can be made within the application. Global downloads and capabilities are available here. And then we also have some select imaging services that are available within the application as well. We're not going to actually spend time making a request for those within the data access viewer because I would like to turn our attention to our newly designed data access viewer enhanced, and we're going to explore some of our new functionality within there. That's okay with everyone. So as I jump over here, we're going to take a look at our data access viewer enhanced. So this is our new application that has been in development. And so as you see here, it has a different look and feel, much updated. I'd like to start within the data access viewer enhanced by giving you guys a tour of the single point tool in here as well, so we can see some of the differences and also some of our added capabilities. And so the form does have some of the same options as we've seen before. So we're able to select our community, a temporal level. We're able to click the map to get our location populated within our form. We can select the date range just as we could in the other single point tool. And then here we're able to have our searchable parameter list here as well, depending upon your community selected. And with that, you're going to also see we have an advanced parameters area that was not previously shown in the data access viewer. So if we open this area here, we now have access to some advanced parameters that were previously only available via accessing the API or querying the API directly. And now we have that available within the application. And we're also going to be able to see some of the charting capabilities directly from our advanced parameters. So you're able to, of course, select your time standard and change that depending upon what your desired time standard would be. We can specify our, sorry, had a snafu there. You just pull it back up. Sorry for that. And so within here, you're able to select your time standard. Our wind surface, and we're also able to select pressure correction. And after I hit submit here, we're going to go ahead and have that pulled up. And so here, after hitting submit, you see our application has our new charting capabilities available within the application here. You're able to hover over to get our data values available directly within the application. You're also able to see our advanced parameters that we selected directly within the application available here for display within our charts. And so we are able to see that already painted out for us, and you're able to make those changes directly within the pane here. We also have available some parameter information. So depending upon your request that's currently selected, you're able to open this up to get some additional details about the given parameter that you selected. And so you can come here, and this is also available within some of our docs within the Power website, but now you're able to access that directly from the Data Access Viewer Enhanced, or the DAV. And then also, this is where you come to find your downloads for your given file format. So the file formats that were previously in the form, you're able to come here and select those downloads, and that's still available with the application. From there, I would like to highlight and show that we still have our regional capabilities available and our global capabilities. But the next tool that I would like to actually walk through live is our added image services area here. So this is called our visualize panel, to kind of hint to the fact that we'll be displaying image services within the application. You see that we have 4 overarching image services available. We have both monthly and annual temporal ranges available for our image services. If I open up this current drop down, you'll see the parameters that are actually aligned to that individual image service. And by selecting one of those, you'll see that we actually have one of the layers visualized within the application here. So this is our shortwave downward irradiance, and that's displayed here. Within this, you'll also see some action buttons available for each layer as once you've selected that. And our first button here allows us to adjust the transparency of that given layer dynamically. So depending upon how you want to visualize that, you're able to adjust that. And that'll actually change that within the application. We're also able to see here our next button that we have available is for us to be able to adjust max and min values. So this is, you can filter out values that are and change the visual directly with your filtering here. So as I filter that, you'll see that some of it hides and shows depending upon if it fits within that data range. And so you'll see that dynamically update within the application. And our last button to the right here is for our comparative analysis queue. And so that kind of leads us into the next piece we'll talk about as far as our imaging services goes. And so if I was to select the imaging services button, it will highlight it will actually open up the comparative analysis queue. And one last thing I want to highlight before heading over to that area here is that we also have timing and time slider capabilities for whichever service you currently have visualized within the application. And so you're able to actually flow through different time slices of that given layer that's already being displayed. You can update that manually by dragging. You can also allow that to play dynamically by pressing the play button here. And so next, I'm going to go ahead and select the comparative analysis action so we can see where that takes us, and then we'll actually be able to demonstrate some of the functionality there as well. So as you see, once I selected that button, we were able to populate what's now our comparative analysis panel is open. And so that adds that particular parameter from that image service over here, and we'll be able to actually compare 2 images side by side once we get that populated. And so what I'm going to do is, I'm going to go through and we can actually choose one parameter from each of these services, and we'll populate that to that comparative analysis queue so we can actually take a look at that functionality. And so I'll select a few here, and we'll see those dynamically show up into that right panel. I'm going to select one more. Select one that's a little fun. Temperature. Oh, that's cool. All right, let's get that out the way. And so now you see that we've populated our comparative analysis queue here. So as I said before, this is so we can be able to compare 2 parameters or 2 images side by side. So this has a drag and drop feature where I'm able to take one of the layers here and drag it up here. If you put it in the right layer, of course, it'll populate to the right side of the screen. So you see here it snaps, and then we have that populated to our right half of the map. We're able to actually slide that back and forth using the swipe tool. And then you're also able to populate that depending upon which side you have that on. You're able to actually have that pull up inside of the swipe tool here. You're also able to have this transparency affected just like you did within the regular application. So you don't lose that functionality from the right side. And you're also able to adjust your max and min values just as before. And within here, you're also able to individually control the time slider here, depending upon, what time slice. You can actually control that within the application here, just as we saw in the middle of the screen. And you're also able to do that dynamically by pressing play. And so as I cleared that out, I do have one more thing I wanted to take a look at, or one more functionality just before we turn it back over. We're going to look at our reports area here. So in this top right corner, we have a reports panel that can be displayed if you click it. In our reports area, we have two different options here. At the beginning, we have climatic design conditions and a climate anomalies area. These are both reportings that were previously available via actually directly accessing it from the API. And it was only available for download. But now we've incorporated the possibility or the actual capability of having that available directly within the DAVE and displaying that data directly in the application. So if you click on climate anomalies, I'm just going to kind of actually run one of these reports so we can get a look and feel for how that looks in the application. We're going to look at heat map today, and we're going to also see here that you have latitude and longitude that also can be directly populated from clicking within the map. You'll see that dynamically update there. I'm going to select a date range here, whichever is good for the user at that given time. And let's run a temperature. So I'm going to submit that. I'm going to allow that to populate within the application. Give that a second here. All righty. So as you see, that pulls up and produces a heat map. And so you see that this bokeh plot, or we're using bokeh plotting to actually have that plot display, and it reaches out to the API and has that populated within the DAVE. So now you can access these charts directly in the application that were previously only available via download or via accessing one of our APIs directly. And with that, that concludes my current demo that I wanted to do. There are plenty of other functionalities that we weren't able to go over in detail. We are aiming to have this available for users on a greater scale this fall. And I'm excited to get it into people's hands. And so with that, I'm going to go ahead and turn it back over to Madison Brown.
All righty, thank you, Shaquel, and thank you to the Powers technical team for their excellent presentation on Powers technical offerings and capabilities. We will now take a break. We will be resuming at 1:10 p.m. Eastern Time. And when we come back, we will all get to hear from Powers user community via a lightning talk showcase from 16 of our users. We will see you soon at 1:10. Thank you.